All right, this is a practice quiz. It's going to look a lot like your real quiz, and I just want to run through and make sure we get these numbers done. So we want to determine the average velocity of the object, and so what that means is we are absolutely going to go ahead and calculate some slopes here. So to get the average velocity, again, this is the slope. Let's go ahead and get it. The coordinate here is 660. The coordinate here is 0, 10. Remember, don't count squares. Actually read off coordinates. So the slope is going to be 60 minus 10 over 6 minus 0. Is that right? Oh my gosh. It's going to be 50 over 6. This is going to be the grossest looking slope. 8 times 6 is 48. 20. Oh my gosh. Long division. So we're going to say 8.3 meters per second. Oh, yuck. Okay. Now, sorry, I just like whole numbers when I do questions. And when I get 8.3 as an answer, that just really disturbs me. Now, we're going to write a mathematical expression to describe the motion of the object. So let's be clear. This is the formula that we now use to deal with objects that are moving in a straight line at constant speed, like our friend the buggy. And this is the physics way of saying it. What we're really saying here, if you want to translate this into algebra language, I would say in algebra language, what we would say is write the point slope form of the line. That being said, be careful, we don't want to use algebra point slope letters. So I'll leave this as the position. 8.3 is the slope. The time remains t because that's the r of the variable. And our y-intercept is 10. Now, that really gives us the answer to the question. So below is shown a velocity versus time graph for an object. It says describe the motion. So here's what I'll say. For the first 2 seconds, the object moves forward at 4 meters per second. It then goes back at 3 meters per second. And finally, it stops. So here we are going 4 meters per second forward, 3 meters per second backwards, and then we stop. So let's actually plot what that looks like on a position graph. So let's be clear. I'll actually count off squares here. So this will be 2 meters, 4 meters, 6 meters, 8 meters, and we'll count off seconds here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 seconds. And so to finish up here, our slope is 4 meters per second. So I'm going to go over 1, up 4, over 2, up 4 like this. Then we go backwards for 1 second at a slope of 3. And finally, we stop for the remaining 2 seconds. So we're using the slope to draw our graph, and that's how we do the problem.